Oh, hey there. You came here to learn some statistics? Well, that's good because I came here to teach you some statistics. So in module one, we're going to go over the very most basic stuff. That doesn't mean it's not going to be challenging, but um, we're really laying the foundations. And I'd say between this first chapter of stuff and the chapter on hypothesis testing, you want to really make sure to nail these down real good and make sure you ask questions and maybe do supplementary reading. Make sure you have a good firm foundation already built because you don't want to try and build on top of that when we go into later stuff. The later stuff in this course really is just build like taking what you already know from the first module or two and just saying, and look, we do this with it, and look, we do that with it. Aside from that, the new stuff that gets introduced is not not too much of a big step up. So make sure you really master the basics. All right. So very most basic thing, what's the difference between an independent variable and a dependent variable? Well, an independent variable supposedly causes a dependent variable. Changes in the independent variable cause changes in the dependent variable. A lot of times when you read news headlines, there's this kind of implied causal or direction of causality. For instance, you might read a study that says, hey, when you consume lots of caffeine, you tend to do better with this, or that your risk for cancer changes. You eat chocolate, you don't get cancer as much. You hear this thing, learning styles. If you learn something in the style that's your learning style, then you'll learn better. And it's really important to get these straight. A dependent variable is the thing that's supposedly responding to or changing as a function of the independent variable. So with the learning styles example, the oh my lord, losing myself already. The learning style example, the dependent variable would be like a measure of how well you learn the material. And the independent variable would be, did you learn based on your learning style or did you not learn based on your learning style? Are you a visual learner, but you learned with a kinesthetic learning routine instead of the visual routine, which you would have been better at? This is when you're choosing the right statistical test to use to answer your research question. This is the very most basic part. What is the variable of interest, the dependent variable? What's the thing that you're trying to change or study? And what things affect this dependent variable? In other words, what independent variables affect the dependent variable? By the way, learning styles are BS. You know what BS stands for? That's right. It stands for bad science. You all were smart. Okay, so here are a couple of more examples. College students who get more sleep perform better on exams. What's the independent variable? What's the dependent variable? A new study finds that depression in rats depends on their early childhood exercise levels. Can you tell me which one's the independent variable and which one's the dependent variable? Women's interest in STEM fields increases as a function of parental academic achievement. And all of these, there's some variable that's supposedly causing the other variable. Either sleep is causing exam scores to change, or early childhood exercise levels is causing depression to change in rats. A lot of studies you read about in the paper or hear about on the radio or wherever it is, people hear about studies anymore. I don't even know. We'll hear about psychological studies or studies that are relevant to health or psychology, and it'll turn out that it's a study that was done on rats, not on humans. So you can take that with a grain of salt. But then again, we are basically talking rats, so not to offend you if you take those studies seriously. I'm not saying don't take them seriously. Women's interest in STEM fields is the dependent variable. You want women to be more interested in STEM fields. There's a shortage, a critical shortage of women in STEM fields. That's science, technology, engineering, and mathematics fields. It's a critical shortage of women. How do you get women more interested in STEM fields? What might be the cause? What might be the independent variable? Might be parental academic achievement. So if your parents have a bachelor's degree or higher, then your female offspring are more likely to be more interested in STEM, according to this headline. So something important to keep in mind, I keep saying supposedly causes. If you're doing correlational research, keep in mind that what you're doing is you're going up to your unit of analysis. If you're a psychologist, this is almost always a human. The individual human is the unit of analysis. You're going up to each human and you're saying something like, what's your GPA? And you write down their answer. And then you say, how tall are you? And you write down the answer. You didn't manipulate how tall people were. You didn't manipulate their GPA. There was no random assignment to experimental conditions like you might have done in your biology classes or something like that. You're just observing two variables out in the wild. And with correlational research, you're measuring the degree to which those variables coincide. Correlations are really just coincidences. If you happen to see that taller people tend to have higher GPAs, maybe it is because the IV was causing the DV. Maybe tall people have more confidence, and that confidence translates over to their grades. In this scenario, it's unlikely that the grades cause people to become taller. Your height is causally prior to your grades. I guess if you really want to squint and really reach, you could say, hey, maybe as you're growing up and you achieve more academically and you receive praise, your hormones, I don't know. That's a tough sell. But a lot of times it's not such a tough sell. Take the example of children who play violent video games. There is indeed a correlation between playing violent video games. You ask kids, what kind of video games do you prefer playing? How long, how many hours in a week do you spend playing violent video games as opposed to like Candy Crush or something like that? Violent kids tend to say that they like playing violent games. So is it the violent games that are causing them to be more violent, or is it the fact that they're violent already? They were violent before they played video games, so naturally they like to play video games that match their behavior. It can be unclear whether the IV is causing the DV or the DV is causing the IV. Another one of my favorites is what's called the third variable problem. That's when something else is causing both of your variables. So let's say your parents are violent and argumentative. That might cause a child to become more aggressive and more violent. And aside from that, the kid might also enjoy media that involves violence and aggression. And it's not that the video game playing is causing the behavior or the behavior is causing the video game. It's just that they're both caused by the environment, the parental environment. With correlational research, you can't really definitively favor one of these scenarios over the other. You can only say that there's some degree of coincidence between them. But it is important to know the difference between an independent variable and a dependent variable, because when you randomly assign people to experimental conditions and you say, okay, kids come in all shapes and sizes. Some of them are on the football team. Some of them are men. Some of them are boys. Some of them are girls. They have different genes. They have different socioeconomic backgrounds. They consume different media. But for today, they're going to be all over the place in these independent variables, but I'm going to randomly assign them. Some of these kids are going to sit down and play a violent video game for a whole hour. And then afterwards, I'm going to observe their behavior in such a way that I can record how aggressive or how violent they're behaving. With that experimental manipulation, I have caused the independent variable to be some value, either violence present or no violence present, and then I'm observing the DV right afterwards. That kind of fixes the direction of causality. if it turns out one of those groups ends up being more violent than the other, it can't be because there's time travel involved. It has to be because of my experimental manipulation. That's why experimental research is good, because it allows you to infer causality much more easily. You can kind of get past these questions of which way are these arrows really pointing in the real world. You can definitely say, well, it's the independent variable causing the dependent variable. I know. All these other questions and all these other possibilities have been rolled out because I used an experimental research design rather than a correlational or observational research design. Of course, one of the drawbacks of experimental research is they're not always realistic. Like if I take a bunch of kids and I make them play Call of Duty or Mortal Kombat for an hour, is that realistic? Am I observing something that reliably like is analogous to something outside of my little artificial laboratory where I study child behavior? Maybe not. And then how long lasting is this effect? Let's say, it is true. When you make kids play violent video games, they do seem to be a bit more violent afterwards, but it's unclear how violent or how long lasting this violence is. Kids tend to just imitate whatever the last thing they saw that abused them. That seems to be their MO. If they just saw someone shooting, if they just saw Space Jam or just watched a basketball game, they're going to start pretending to play basketball. And if they just watched an action movie with machine guns, they're going to act like action stars, go in the backyard and act like they have M16s and grenades and stuff. They tend to just kind of imitate the last thing that entertained them. So there are still questions that remain with experimental research. You can't just throw your brain away, but it at least gets rid of these questions of, okay, we observed a coincidence, but what's causing what? So that was a lot to talk about independent variables and dependent variables. I call these IVs and DVs for short. That can be a little confusing to newcomers, so I definitely suggest practicing. The more you read and the more you watch or rewatch this video or other videos about independent variables and dependent variables, just kick on Netflix and just say, hey, talk about stats for me, talk about IVs and DVs, so I get used to the acronyms. It gets easier with practice. The last thing I'm going to talk about in this short kind of part one video is something having to, it's called levels of measurement. So we talked about how variables can be independent or dependent. Variables also are they're categorized based off of what kind of values they can take. So if I'm doing a survey on college students and I want to know, are some of the trends I see in the data, are they the same for men versus women? That would be a categorical value. Are you a man? Are you a woman? I can put a third category to be more inclusive. Calling it miscellaneous might not be very nice, but saying non-binary or prefer not to say could be a third variable. If there's a limited number of levels within the variable, like you can only be male, female, or third level of the category, which is basically miscellaneous. That's a categorical variable. There's a limited number of values. You can, and this is crucial, you can only be in one group in a categorical variable. You're in the control group or you're in the experimental group. You can't be half and half. You can't be sort of in one and sort of in the other. The categories have to be mutually exclusive, and you should try to make them as exhaustive as you can. So if you want to do a study on, this is a bad example, let me think of another one, college major, don't just have, are you a history major, a psychology major, or a business major, or a nursing major? You try and think of all the majors, and then you find out, oh, there's photography. I forgot about photography majors. Oh, there's creative writing. I forgot about that. You got to make sure your categorical variables cover all of the potential levels of that category. So this is the low end of the scale, but it's very important. A lot of variables you're going to be dealing with are categorical variables. Ordinal variables are kind of an evolved version of categorical variables. An ordinal variable has that same, you're either in category 1 or you're in category 2, but the categories have some sort of order to them. So the example I was going to use earlier is I was going to say, what if you want to study trends over someone's time in college from freshman to sophomore, junior, and senior? Well, those classifications aren't just categories because there's an order to them. If you're a sophomore, that comes after being a freshman. If you're a senior, that comes after being a junior. Ordinal variables give you information about the rough kind of relativistic order in which the variables come from, but not kind of an absolute value. For instance, if my horse won first place in a race, in a derby, and yours won second place, that tells you in an ordinal sense that my horse was faster than yours, but it doesn't tell you anything about how fast my horse was just in and of itself. Your horse might have finished right after my horse. They might have been neck and neck, and my horse just barely pulled out at the end. Or maybe my horse was like way ahead of all the other horses. That's what you get with ordinal variables. They're just these categories. High GPA, low GPA is kind of an ordinal categorical variable. Going up the measurement scale, you have two levels of measurement that are both considered, can you see this? They're both considered continuous. A continuum, technically speaking, a continuum is a range of values that are infinitely divisible. Technically, theoretically, they can take on between two extremes, like anything between these boundaries. So technically, if you did a study on weight loss, you could have one person that's 200 pounds when they start your study. You could have someone that's 201 pounds. You can have someone that's 201 pounds and 1/2 of a pound. You can have someone who's 201 pounds, 0.111 or 112, or you can have decimal dust after. Basically, they can take on any weight, however precise your scale is. But you see, that's where in practice, we don't track people's weight down to like a 1/1,000,000th of a pound. That would be kind of pointless. The idea with a continuous variable, though, is that technically or theoretically speaking, your variable could take on as many values as, like, there's no limit to how many values they technically could get to, but there's maybe practical constraints on which values we can actually observe. But obviously, with height lies on a continuum. That means you can be any height, but there are boundaries, right? So there are very few people who are above 8 foot tall. I don't know who the tallest person ever is. Let's say 10 feet, just being crazy. You can be anywhere from 0 feet to 10 feet, but no less than that. You can't be -feet tall. You can't be taller than the tallest person possible, but you can literally be, like, theoretically any height between those two boundaries. That's what a continuum is. Many variables get treated as if they're continuous variables, like IQ, scores on the personality test. Like if you're interested in degrees of narcissism or degrees of mischievousness, if that's what floats your boat, technically, theoretically, though, your degree of those personality values can be anywhere on a continuum, and we treat them as if they lie on a continuum, even though practically speaking, they might not lie on a continuum. Within this broad category of continuous variables, there's kind of a tricky distinction between interval levels of measurement and ratio levels of measurement. I'm going to start with ratio because it's actually kind of easier to talk about. If I weigh 200 pounds and you weigh 100 pounds, then I weigh twice as much as you. If I have an IQ of 200 and you have an IQ of 100, that doesn't mean that I'm twice as smart as you. You see, with a ratio scale, we're talking about quantities that have a legitimate proportionality to them. Uh, People often say what defines a ratio scale is that there's some non-arbitrary true 0 point. Like technically there is such a thing as having a height of 0 or a weight of 0 or a reaction time of 0. And I mean, that is more of a prerequisite to being on a ratio scale of measurement, but I think it makes more sense to define it in terms of, it says ratio in the name. You can put a ratio of my score versus over your score over my score, and there can be a legitimate sort of mine is 15% higher than yours, or yours is, 85% of mine. There are these quantities that can be said to have an actual ratio relationship. These are usually physical quantities like reaction time, speed, in general, time, weight, height, length. These are all measured on a ratio scale. If you're a physical scientist, probably most of the things, most of the variables you'll deal with are on a ratio scale. Most things psychologists deal with are on an interval scale. And what it means to be on an interval scale is that we will give you a number that can be anywhere on a continuum, but those numbers don't necessarily, or if you're not ratio, then you're definitely not, in a sense, representing numbers that have that kind of meaning to them. Like I said, if I have an IQ of 200 and you have an IQ of 100, that doesn't mean I'm twice as smart as you, because IQ scores are on kind of an arbitrary scale. BDI, Beck Depression Inventory, scores are on an arbitrary scale. You could say I have a Beck Depression score of 40 and you have a Beck Depression score of 20. Does that mean I'm double as depressed as you are? No, because degrees of depression is not measured on a ratio scale. It's measured on an interval scale, which means it's on a continuum but doesn't have this ratio quality to it. So that's a very tricky distinction. I did my best to give kind of a quick and dirty kind of introduction to it. I'm probably not going to have an exam question on it. If I do, I'll stick very close to how I explained it. And that's going to be the end of part 1. And the second part, I'm going to round out everything from the chapter 1 that I posted. So I'll see you all then.